Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss transistor configurations and current gains with their relationship. Let's begin. Transistor configuration. In the previous video lecture, we see two varieties of transistor. One is NPN transistor, another one is PNP transistor, as categorized under bipolar junction transistors BJT. Let me take a NPN transistor. This base, emitter, collector, the base, emitter, collector. Since it is a NPN transistor, NPN transistor, so the arrowhead just like this. This is base, that one is collector, that one is emitter. When we connect taking base and collector and base with emitter, base and collector, base and emitter, then it is treated as common base configuration, base as common. Similarly, if I connect taking collector as common, a connection to collector to emitter and a connection to base to collector, then it is termed as common collector configuration. Like this way, taking emitter as common, so a connection towards emitter to collector and emitter to base, then it is called as common emitter configuration. On that basis, transistors are configured common emitter configuration, CE, emitter as common. Next, common collector configuration, collector as common, CC. Next, taking base as common, that type of configuration is known as common base configuration, CB. Any one of these configurations can be useful to configure a transistor. The transistor either NPN or PNP under BJT, bipolar junction transistors. Let we have to understand it in terms of current flow mechanism. As we take NPN transistor, N type semiconductor, P type semiconductor, again N type semiconductor, that one is emitter, this one is base, that one is collector. Emitter, it is heavily doped in N type. The majority charge carriers are electrons, which are heavily doped. And less wider as comparison to that of collector. In P type, it is very thin and it has less doped. Here the majority charge carriers are the holes, small amount of holes. That one is the collector. It is less doped and much wider as comparison to that of emitter. Free electrons are the majority charge carriers. We configure that NPN transistor as common base configuration. That one is the base. An important point we notice here, a transistor is active when its emitter base is forward biased and collector base junction is reverse biased. So, emitter base junction, it must be forward biased. For N type, negative terminal, P type, positive terminal, negative terminal, positive terminal, and that potential emitter base potential. Again, for collector base junction, that is reverse biased and that potential is much more as comparison to that of emitter base junction potential. Reverse biased, negative, positive, negative, positive, potential V, collector based potential. That is the configuration of a common base NPN transistor. Common base NPN transistor. Let we understand the current flow mechanism in common base NPN transistors. Since it is forward biased of that emitter base junction, so electrons are from this N side to p side, and again since p type is lessly doped and very thin, so electrons passes through that of n type. Let we understand it by taking some number. If in n type there are 100 number of free electrons, 100 number of free electrons, from that 100 number of free electrons, let 95 number of free electrons are passed to that of n type, and 5 number of free electrons are passed through that of p type. And the direction of flow of that free electrons just like this. Since we are related with conventional current, so conventional current direction is just opposite to that of direction of flow of electrons. In that situation, the conventional current direction just like this, the direction of flow of electrons, the conventional current flow direction, that free electrons again within this, again it is completed that circuit. So here that current is known as emitter current, that current known as base current, that current as collector current. Here I of E, that is emitter current, I of B base current, and I of C collector current. From this it is clear that I of E is the sum of I of B and I of C. It is clear that emitter current is equal to base current plus collector current, that equation number 1. Now we introduce a technical term, that is current gain. Current gain is a term on which we can relate how these currents are related with each other. Means what be the relation between emitter current and base current, emitter current to collector current, base current to collector current. It can be defined by using current gains. So current gains we define it as that alpha, that is the relation between how collector current is related to emitter current. So emitter current is what amount of collector current. On that basis, alpha is related as collector current to emitter current. Similarly, beta how collector current is related to base current. How a collector current is related to base current. B, I of B, I double I, and gamma, how that emitter current is related to base current, IE, I, B. Now we have to draw the relation between these three terms alpha, beta and gamma. As we know, IE is equal to IB plus IC, as emitter current is the sum of base current plus collector current. Let we divide IE on both sides. So IE divided by IE is equal to IB plus IC divided by IE. IE by IE 1, here IB divided by IE plus IC divided by IE, or 1 is equal to IB by IE, IB by IE 1 by gamma plus IC by IE, IC by IE, it is alpha, or here alpha is equal to 1 by gamma, alpha is equal to 1 minus 1 by gamma, or alpha is equal to gamma minus 1 divided by gamma. Equation number 2. Again IE is equal to IB plus IC. Emitter current is the sum of base current and collector current. Let we divide it. IC, divide IC on both sides. So we obtain IB by IC plus IC by IC. Here IE by IC, IE by IC 1 by alpha, 1 by alpha is equal to IB by IC, IB by IC 1 by beta, 1 by beta plus IC by IC 1, or one by alpha is equal to LCM as beta 1 plus beta, or alpha is equal to beta divided by 1 plus beta. Equation number 3. From equation 2 and 3, from equation 2 and 3 we get alpha is equal to beta divided by 1 plus beta is equal to gamma minus 1 divided by gamma. That is the relation between alpha, beta and gamma. This is the relation between current gains. So with the help of this particular video lecture, we understand the concept of transistor configuration as common emitter, common collector and common base configuration. How we can understand emitter current, base current and collector current in terms of a technical term, that is current gains, as alpha, beta and gamma. How these currents are interrelate with each other, and the relation between alpha, beta and gamma, how these three terms are interrelated with each other. So, with this useful and informative notes, let me wind up this session. Thank you.